Aketsas meter magas megatsunami acosta. Hogi afilled megremeget kilens napig. Scientists have identified the cause of a mysterious seismic signal that lasted for 9 consecutive days in 2023, revealing that a massive tsunami triggered by a mountain summit collapsing into the sea was responsible for the prolonged tremors. In September of last year, an unusual seismic signal puzzled scientists. Researchers now attribute the earth-shaking event to a megatsunami trapped within a fjord after a mountain peak collapsed, according to Live Science. The colossal 200-meter-high wave rocked back and forth inside Dickson Fjord in East Greenland for 9 straight days, causing seismic waves to reverberate through the Earth's crust. When we embarked on this scientific expedition, everyone was baffled, and no one had any idea what could be causing the signal, said lead researcher Christian Svenevig, a geologist at the Geological Survey of Denmark and Greenland, GEUS. All we knew was that it was linked to a landslide. We were only able to solve this mystery through interdisciplinary and international collaboration. After seismic monitoring stations detected the signal last September, 2 characteristics puzzled the researchers. First, unlike high-frequency earthquakes, it oscillated with a 92-second interval between peaks. Second, it lasted for days before fading. The team quickly associated the signal with a landslide in the fjord. But to fully understand how the signal was generated, they combined field measurements, satellite imagery, and supercomputer modeling to reconstruct the event. Their investigation revealed that a massive landslide likely caused the tsunami to surge through the narrow fjord, a phenomenon known as a seiche. According to study co-author Alice Gabriel, a seismologist at the University of Munich, accurately simulating such a long-lasting tsunami posed a major challenge. The landslide that created the gigantic tsunami was a direct result of climate change. Melting ice around the polar regions is accelerating at an alarming rate. In the case of Dickson Fjord, the tsunami dislodged 25 million cubic meters of rock and ice, equivalent to 10,000 Olympic-sized swimming pools, into the sea. While no one was injured in the collapse, the tsunami destroyed $200,000 worth of infrastructure at an unmanned research station on nearby Ella Island. The researchers warn that the worsening impacts of climate change could lead to even more severe landslides in polar regions. The team hopes their discovery of the seismic origins of the tsunami will inspire others to investigate seismic records for similar events, helping them identify the precise conditions that lead to catastrophic landslides in polar areas. Initially, the team was perplexed by the signal. However, through satellite imagery and ground photos, they eventually traced the seismic activity to a destabilized mountain, weakened by climate change-induced glacier melt. The researchers published their findings on September 12th in the journal Science.